All right, so continuing where we left off on Wednesday, we're going to discuss probabilities of more than one event. So we'll start with this one. Which is the same thing as probability of A or B. Okay, and again, we're just doing some basic stuff here. We're not going to get into much depth, just kind of some ins and outs and some things that should generally help you. Best way to explain, well, here, 99% of the time, probability, when you see the word or, you're going to be adding the probabilities together. Okay? If you see the word and, which we'll do an example of that in a minute, 99% of the time you're going to end up multiplying the probabilities together. Okay? Now, with the or probability, you are going to add the probabilities together, and you're also going to subtract any repeats, meaning any overlap. So if we're talking Venn diagram, think of that picture, right? If you count probability of A, probability of B, you know how there's that part in the middle that gets counted twice, right? If I ask you what's in A and then what's in B, you'd count this little shaded part twice. That's what this represents, subtracting out one of them because we counted it twice. Okay? So this is your formula for an OR. Union, yeah. Union and OR mean the same thing. I could also, you'll probably see this symbol sometimes. Okay, and or intersection, same thing. Alright, so we'll do a couple of examples using this formula, and you'll see that you probably could do it without, but it's good to go through the formula so that you know how it works. Okay. Let's say again that we're picking one card, and I want to know the probability that it is an ace or a spade. Okay, so simply we find the probability of picking an ace, or means add, plus the probability of picking a spade, and then we subtract the probability that we pick an ace and a spade.
Right, so if it's and spade, does that mean it's
Say that again? If you sure?
Yeah.
Okay. So looking at each one of these separately, how many aces are there in the deck?
4.
Out of?
52.
Good. Spades, there are 13 out of 52. And now this is going to account for the fact that we counted one of those cards twice, didn't we? Because we counted an ace of spades in this group of 4, we counted an ace of spades in here as well. There is one card that is an ace and a spade. So we subtract 1 out of 52 from that.
That would be the case in all times.
What's that?
If it wasn't an ace,
If it wasn't an ace?
yeah.
What do you mean?
What's another?
It could be any card. It could be a heart, or it could be a king, or a jack, or a 2, or a 6. It'd be the same exact calculation.
If it was a heart, would it still be 102?
If it was ace or heart,
No, if it was heart or spade.
heart or spade, that's it. Hold on, I'll answer that in a minute. So what is it? 16 out of 52, right? Which reduces to 4 out of 13. Is that right?
Yes.
Okay. Now, this is a scenario where, I mean, some of you are intuitive enough that you probably could just count how many cards are aces or spades. You know what I mean? Like, you know there's 13 spades in the deck and that there's 3 more aces, so 16. I mean, you could probably have thought about it that way, too. John, your example, if you're picking a card and you want to know probability that it's an ace, or I'm sorry, not an ace, you said heart, or a what?
Or spade.
Oh, great. Okay. Spade. That's not a very good spade. We'll pretend it is.
This is a mushroom.
That's what I said.
I'm sorry, I couldn't hear you.
Oh, no, I'm not.
I'll write it out. Spade. Okay. Let's think about it first, and we'll use the formula so you can see that it's the same thing. What do you guys think the probability would be of picking an ace? Or, I'm sorry, a heart or a spade?
Something of 26 out of 50.
Half. Yeah. Half, right? Because you're talking about half the cards right there. Okay? Now, if we use the formula, probability that it's a heart plus probability that it's a spade minus the probability that it's a heart and a spade, it'll get us to the same place. How many hearts are there?
13.
How many spades? How many hearts and spades? Okay, so we still get a half, 26 out of 52.
Why is it 0? Yeah, what is it?
Can you pick a heart and a spade? Is there such a thing?
Like the ace of hearts and spade.
Oh.
That's big.
Right? You can't have a card that's two suits in one.
Joker. I got it.
I don't get it. Yeah, I don't study my different cards. Yeah, I don't get it.
You don't get this?
I don't know my
Hold on, I have a deck here somewhere. If we're picking one card, right? Let me get spade, club, heart, diamond. This is what a diamond looks like. Heart, club, spade, right? If we're picking a card, and this last part is supposed to be combining that we get a card that is a heart and a spade. There's no such thing. It's got to be one suit only. There are 0 cards that are hearts and spades. Does that make sense? Where in the other scenario, this is great that I randomly pulled this card out. When we're looking for an ace or a spade, an ace and spade makes sense. Because this is both an ace and a spade card. Does that make sense? Okay, so that's how we actually have something in the formula there to subtract. So,
Wait, so there's a question in the tablet quiz I can't get it.
you can ask me about the deck of cards if you're confused. All you need to know is that there's 52 cards, 4 suits, and within each suit there's 13 rankings. You know what the rankings are? It starts with an ace, then it goes to 2, and then 3, and then 4, all the way up to 10, and then there's a jack, queen, and king. Okay. I've already shown you my magic trick, right?
No.
I, I haven't shown you one?
No.
Oh, well maybe if there's, I'll show you one after I'm done. Okay.
Could you put it on camera too?
Well, the camera wouldn't help because you wouldn't see what I was doing. Okay.
Oh god.
And probabilities. When it was or, we said, for the most part, you're going to add. When it's and, we're going to multiply. Okay, so we'll just do a couple examples. What is the probability that you pick 3 kings in a row? And I'm going to say you replace. So here's what replacement means. So here's what I'm doing. I'm shuffling the deck. I pick a card. I get a king. Hooray. I put it back in the deck. I shuffle it up. Do you see what I'm talking about? So there's still 52 cards, and there's still how many kings?
4.
So every time I pick a card, it's 52 cards, 4 kings. Does that make sense? All right. So in order for me to get 3 kings in a row, 3 things have to happen. Okay. So listen to the words I'm going to use. The first draw, I have to get a
King.
And the second draw, I have to get a king. And then the third draw, another king. See how we're saying and? There's no or there, right? So we have to get, it's the probability of a king the first time, and a king the second time, and a king the third time, all in a row. And means multiply. So we have 3 probabilities we're going to multiply. And what is the probability that I get a king on the first straw? 4 out of 52, because there's 4 kings in the deck. I put it back in, shuffle it up. What's the probability the next time? Does that make sense to you guys? Same with the third one? Okay, now we need your help. Well, it's 1 over 13 if you reduce the fraction to the 4th. Anybody got it?
What's 52 times 52 times 52? A big number is the answer.
You could also, 1 out of 13, 1 out of 13, 1 out of 13, 169 times 13, whatever that is, that's the denominator. What is it?
2,100. Did I try to get 3 kings in a row?
No. Not now.
Did you say 2,100?
What about the probability that you pick 4 hearts in a row? And this time, let's do it without replacement, so you get the idea for it. So what does without replacement mean? Well, yes and no. Part of it's right, part of it's wrong. If I pick a card, oh, look at that. Pick a card and I get a heart, and I'm not putting it back in the deck. Now there's how many cards? 51. And how many hearts are left?
12.
12. Does that make sense? So if I need to get 4 hearts in a row, I need to get a heart and a heart and a heart and a final heart the 4th time. The first time, if I need to get a heart, there are 13 out of 52. The second time, there are now 12, and also the total of cards goes down to 51. Does that make sense? So what are the next 2? Yep. Good. And I need help with that. What is that going to be?
That is such a beast right here.
What is it?
11 over 4.65.
Thank you. Was that a Sports Center text message?
Of course you would know this, Jude.
Of course I would know what.
Dun-dun-dun.
Who doesn't know that?
Did you watch my commercial that I made? No. It was about basketball.
Okay.
Was he good?
It's pretty funny.
What else can we do? One more thing. Compliments. Last one.
Compliments I can give you. You
I
look
like that shirt.
really good today.
Thanks.
You look good every day.
Oh, even better. Thank you.
Thanks, guys.
All right. Not that kind of compliment.
Talk it to you.
We talked about this notation, right? On Wednesday?
Yeah.
What does this mean?
Not
Not an A, right?
A or not?
So compliments mean not. Think of it that way, right? So, easy example to understand. We have 4, 6, 8, 9, 12, 15. We have 19 people here today. 1, 2, 3, 4 are girls.
You guys
You
really
forgot
don't know.
John.
You're so funny, man. You're so funny, man.
Okay, guys, come on. So we got 4 girls out of 19 students. Okay? So 19 students,
21% of the class is girls.
4 girls.
Yeah.
So if I ask you, what's the probability that if I just pick a student at random that I choose a girl? 4 out of 19, right? Well, what's the probability that I don't choose a girl. What does that mean?
15 and 19. That's not it.
Okay. How'd you get 15?
19 minus 4.
Ooh, I like what you said. Minus, right? Now, what happens if I add these two probabilities together? Which is? So, in other words, the probability of G plus the probability of the complement of G is 1. Okay? This equation right here, whether it's girls, boys, or it really could be anything. Doesn't matter what it is. Okay? This is your probabilities all added up. So if you have a gigantic sample space, here we only have two scenarios. You're either a boy or a girl. Unless there's something you guys aren't telling us. But, okay? You're one or the other. Let's assume that. When you add up the probabilities, you get 1. Okay? Another scenario. If I roll a die, how many outcomes are there? 6, right? If I add up the probability that I get a 1 with 2, with 3, if I add up all 6 of those probabilities, what do I get? Does that make sense? Okay. So here's a formula that might help you. The probability of the complement of any event. If I solve this equation and get this part alone right here, what would I get? 1 minus the probability of whatever event G is. Okay? And this is actually, if you remember my birthday problem story and my bowling alley experience, this is how I calculated that.
Did you really?
Mm-hmm.
And he got $50.
Yeah, it was
Hey,
good.
that's what we talked about your
Okay, we are done. Farewell.